Hi there, this is Courtney, Emmy, and Alana, and this is our Engineering 330 project, and this is our Part 1 video for our Simio model. So for this project, we are supposed to create the Littlefield simulation model in Simio. We're supposed to conduct various experiments in Simio and or other design of experiments to analyze and optimize our manufacturing system for about 365 days of operation. Then based off our Simio model and other experiment results, we're supposed to determine the optimal settings for our variables, such as our number of machines for each station, and then our order types, and also our inventory policies.
Okay, so here we have the Littlefield simulation that we were basing it off of. This is the layout of it, and it's basically saying that we have 3 different machines, as Courtney was talking about, and we go through it using an understanding of operations management, and we look at our utilization and the number of jobs we're completing.
Alright, so the way that we developed a good model to be able to put into our Littlefield model that we had was we did a Simio model, and we were able to replicate what we had in in Littlefield, and put it into Simio. So I'll show you real quickly what we did in Simio. Alright, so this is the Simio model that we created. As you can see, it is exactly the way like the Littlefield model is. We've got these entities, which is the model entities, are the jobs. It starts off in a source called orders, ends up going to the first station, stuffing, then ends up going to testing. From testing goes to tuning. From tuning it goes back to testing, and eventually ends up in our completed folder. The way this was done was we were able to put through a data file, sequence file, we were able to put in a sequence for the model entities, so that when we hit play, we can watch the jobs go through the process. As you can see, the box starts off with the orders, goes into the stuffing, and all of these were used information. We were able to mine the information from Littlefield for the first 50 days and put in the type of information, for example, the processing time of each station, the quantity in each station, and we were able to get a very, very good model of what we had in Littlefield. And the way we were able to test this model was we already had the information from Littlefield, but we designed an experiment. So I'll pause this right here, go to the experiment, and show you guys some of the results that we had. So here we've got, we're looking at machine utilization and these responses, as well as throughput, and these are what we're going to compare to what we had in Littlefield, as well as we have, this is the number of machines actually for stuffing here, for testing here, and for tuning here. So one machine for stuffing, one machine for testing, one machine for tuning. And we're able to run 20 replications of each one, get in an idea of what our stuffing utilization will be, our testing, and then find out if our model is very accurate to what we have in Littlefield. So this is what we got. With this information now, we're able to take this information, put it into SAS Jump, and get ourselves a better idea of what an optimal solution will be. So here you can see I've pulled up the, I've pulled up the information that we have. We've created a model for it with a custom design of experiments. We've put in all of our information back from Simio into SAS Jump, and we're able to actually get a custom design of experiments. We go down to Prediction Profiler, and the Prediction Profiler will actually give us an optimal solution for the constraints that we gave it. And as we can see in here, the optimal solution for the stuffing, these are the number of machines, is four machines for stuffing, 2 machines for tuning, and 2 machines for testing will give us our highest desirability. So that is how we used SAS Jump and Simio to use the information to be able to put it into Littlefield. So back to our PowerPoint slide, we were able to put in our Simio results into our PowerPoint slide. Again, this is the same thing that I've showed you before in Simio itself. And our optimal solution was actually highlighted here, where we're at 4, 2, and 2 when it came to machines for each station. And these are utilizations and our throughput, as well as our results from SAS Jump and our design of experiments. The same information that we got from Simio, we were able to insert into the SAS Jump, and this is our desirability that we got from SAS Jump as well.
So based off our results in Simio and in SAS Jump, We determined that our optimal settings for Littlefield should be that Station 1 should have 4 machines, Station 2 should have 2 machines, Station 3 should have 2 machines as well, and then our order types, we should keep it at first in, first out, and then for inventory policies, our reorder point should be 3,300 kits, and our reorder quantity should be 3,600 kits.
Okay guys, so this wraps up our Semio model. So stay tuned for part 2, which is the Littlefield model.